All right, let's talk about one of our final topics, section 7.4, parallel and perpendicular lines. You can see the graph on the left has the red and blue line and they meet a 90-degree angle. Those are perpendicular lines, and the lines on the right that look like the typical railroad tracks, those are our parallel lines. All right, here's a set of two lines, and what we're looking to figure out is, are these lines parallel or not? Well, you can do that by trying to figure out what the slope is. So we would count the up, 1, 2, 3, 4, 5. We count the over, 1, 2, 3, 4, 5. The slope is 5 over 5. Well, we could pick any 2 points on this line. If I pick these 2 points, I'm going to get a bigger ratio, and I'm going to get 10 over 10. But what's the same as 5 over 5? 1, and 10 over 10 is 1. So the parallel lines are equivalent, or are parallel, if their slopes are the same. So they can be different fractions as long as they reduce to the same thing. Here is another set of parallel lines. You can see this time that with the blue line I have 6 over 3. So rise over run would be 2. So it's a ratio of 2 up, 1 over. So 2 up, 1 over, 2 up, 1 over, 2 up, 1 over. That'll work the same on the next line. All right, perpendicular lines, well, you can see obviously they're not parallel and they have definitely a different relationship. The first thing I want you to look at is the two types of slopes. This has a positive slope and this has a negative slope. So when you have pairs of lines that are perpendicular, you have one that's positive and one that's negative. Now, let's look at the slope. Well, the slope of this one will be 1, 2, 3, 4, 5 up and 5 over. And if we look at this one, well, what do we notice this time? It's minus 5 over 5. So this has a slope of positive 1, and this has a slope of negative 1. This isn't the best example to show the relationship of slope lines that are negative reciprocals, but the relationship between two lines is if one line is a over b, the other line is minus b over a. Now, something special happens when we multiply these two lines. We actually get minus 1. So the product of two perpendicular lines is minus 1. All right, let's have a look at this set of lines. So let's again count 1, 2, 3, 4, 5, 6, and 1, 2, 3. This is our positive line. This one has to be our negative line. This would be 1, 2, 3 over 1, 2, 3, 4, 5, 6. All right, so that shows the relationship between the two slopes a little bit better, as we have one positive, one negative, 1 6 over 3, and 1 3 over 6, and we call this relationship the negative reciprocal. Or the sort of generic way of saying it is flip the slope and change the sign for the second slope. All right, let's have a quick look at how to come up with equations of lines that are parallel and perpendicular to a given line. So the first thing you're going to notice is that I've given you an equation. It has a slope of minus 2 over 3x. So first thing is we know that the slope of a parallel line will be minus 2 over 3. You can have any intercept or the same intercept. If the two lines are the same, we'll talk about those next unit, they're called coincident lines, and if the intercepts are different, then they're parallel lines. So if you knew what this intercept was, you could just make any one you wanted, plus 3. So if it's perpendicular, it's going to be the opposite sign, and it's going to be upside down. So positive 3 over 2x, I don't know, plus 6 works. So that's a very simple way to come up with two equations of two lines, one that's parallel and one that's perpendicular. All right, let's have a look at how do we come up with equations in general for lines that are perpendicular and parallel. Well, let's start with the slope. 10 minus 7 is 3, 5 minus 4 is 1, 3 over 1 is 3. So this one's easy. If we want to do it in slope-intercept form, we could have 3x plus b, and we would know here it's y equals minus 1 third x plus b. Now you guys all know you can just pick a point, so I can pick 7 equals 3 times 4 plus b. 3 times 4 is 12, 12 minus 5 is 7, b is minus 5, so the equation is 3x minus 5. Same thing, I can pick a line. This one's, of course, is going to be a little bit uglier because we're going to have, unfortunately, 7 equals minus 4 thirds x plus b. I'm going to add 21 thirds plus 4 equals b. So in this case, b is equal to 25 thirds, and I'm going to get y equals minus 1 third x plus 25 thirds. So that's how you come up with two equations if you're given the 2 points. You just find the slopes and do substitution. Thanks. All right, let's use slope point form to come up with two equations of lines that go through particular points. So again, we'll start with the very beginning. Let's look at the slope. So the slope of this would be 12 minus 3 is 9, and 7 minus 4 is 3, 9 divided by 3, therefore our slope is 3. All right, so slope point form, if you remember, is y minus y1 equals m times x minus x1, and it really is just this easy. Y minus minus 2 is plus 2, and put in our m, 3, which is x minus 1. All right, let's look at perpendicular. So again, if we rewrite the equation, y minus y1 equals m bracket x minus x1, the first thing we have to know is that our slope is now from 3 to minus 1 third if it's perpendicular, and then x minus 7. That's it. Using slope point form is easy as pie. All right, let's do the last type of question. This is where the rubber hits the road, where we do all the questions at one time. So let's ask ourselves the question, what's the easiest type of equation to write given 2 points and a slope? Well, my favorite point is equation is now slope point form, so I'm going to use the first point, y minus 3 equals 3 bracket x minus 4. There's slope point form. Now I'm going to get to, how about we get to y-intercept form? Have to expand the brackets, and now I'm going to bring over the 3x minus 9, and there we have it, slope-intercept form. The third type of equation is general form, and if you can see, we're almost there, one step away. 3x minus y minus 9 equals 0. That's general form, and there we have it. We've come up with all 3 equations. All right, let's do all 3 equations with a slope that isn't as easy to work with, so let's stack them in our head. 7 minus 3 is 4, 5 minus 2 is 3, so our slope is 4 over 3. Well, let's start with slope point form again. Let's use the first point, which would be y minus 3 equals 4 thirds x minus 2. Now notice I don't usually put a bracket on the left-hand side, but we do need it for the next step. So notice that we have a 3 down here. Well, there's a couple ways we could get rid of it. We could expand first and then multiply by 3. I prefer to multiply by 3 first. So let's multiply both sides by 3. 3 bracket y minus 3 equals 4 thirds times 3 bracket x minus 2. For those of you who were with me before, you know I love to cancel, so I'm going to cancel 3 divided by 3 as 1. Or you can do 4 times 3 is 12 divided by 3, still gets you 4. So now we're going to expand both sides. 3y minus 9 equals 4x minus 8. And now from here, it's just really a matter of personal preference. Which form do you go to next? Well, let's go to general form. We're almost there. So let's bring everything over. So 0 equals 4x minus 39 plus 1. There's our general form. And all we have left to do is find slope-intercept form. And we have to get y by itself. So if we bring the y back, it becomes positive. 3y equals 4x plus 1. Divide both sides by 3. And you get 4 thirds x plus 1 third as your y-intercept. And now you have slope-intercept form. You have general form. And way back here, we had slope point form. So there you have it. That's all there is to say about lines in this chapter, so hope you found this series helpful.